Welcome to Chapter 9 review in our power transmission course, IMT 110. And today we're going to be learning about lubrication. The chapter is very, very important. We did skip chapters 7 and 8 in terms of a formal Zoom session, but I'm urging you strongly, take a look at chapter 8. It's going to be very useful for the lab. However, we're talking about chapter 9 today. Lubrication is probably, from a mechanical system standpoint, the single most important thing you can learn in mechatronics from a mechanical system standpoint. Now, obviously, we've got electrical systems in mechatronics that are extremely important as well. But if you don't lubricate it, it will probably break in most cases in the mechatronics world. It's true we are having more and more modern tools out there that give us, based on the materials like some super high density plastics and so forth, that don't need to be lubricated, but still 98% of what you're going to run out in the real world needs to be lubricated. One reason why our vehicles last now 10 years or even more, 200,000 or 300,000 miles, our engines can run so well compared to what they were even 20 or 30 years ago. One reason for that is because of the improvements in lubrication. Lubrication is not only useful in the mechatronics world and the maintenance world, but it's also extremely important in just maintaining your own vehicles and your own equipment around the house. So I would urge you guys to be comfortable with the process of lubricating all your own stuff. And that includes changing the oil in your vehicle if you have any capability for doing that work. So, Chapter 9, objectives. Number 1, we got to talk about the terms. The terms in lubrication are very important. You want to sound smart whenever you ask for the right parts. You want to sound smart to your bosses when it comes to doing the work out in the field. We're talking about why, and we're going to talk about what. And we're going to go through the basic types of lubricants in the fields, in the industry out there. And then we're going to talk about different applications. And last, but certainly not least, we're going to talk about a maintenance schedule or a lubrication schedule. Okay, so in chapter 9-1, first section, we touch on some general terms, and these are all really important terms. Obviously, a lubricant can be any substance. It doesn't have to be oil. We've got solid lubricants like graphite. We've got liquid lubricants, and we've got greases, which are kind of somewhere not quite liquid, usually a gelled up liquid. The thickness of that grease or that liquid lubricant like oil, that thickness is called viscosity. Viscosity is a very, very important term. When it's really hot outside, back in the old days, we had a special higher viscosity lubricant we would use in our cars. I don't know if any of you guys remember those days, but in those days, you would run a summer viscosity oil in your car in the summer. And then when it came to winter, you would change that oil out for a thinner, lower viscosity oil. We don't really have to do that anymore because oil has advanced so much that the viscosity of the oil changing from season to season has become less critical. So viscosity really is just talking about how thick it is. The higher the viscosity, the thicker it is. The lower the viscosity, the thinner it is. Hydrocarbon is just talking about anything that has, kind of a carbon chain in it, which is, basically the nature of anything you get out of the ground like oil. And semi-solid is obviously grease, gel-like substance. So the book talks about in chapter 9-2 the different kinds of lubricants. It goes through them, touches on some of the things I mentioned here, talks about additives, what you add to that lubricant. And additives are a two-edged sword. In some ways, they really help that lubricant perform better. Like the additives we have in modern lubricants for our vehicles today is incredible. They really help maintain viscosity despite the temperature. They help keep it long-lasting. They add additional things into it that will help keep your car running better, smoother for longer. And so, but the other edge of that sword is additives can also add danger to you. So you might have some additives in lubricant that may not be healthy for you. So you might want to wear gloves. You may not want to drink the product, or even have some splash on your face. And you should always check your MSDS to make sure that you know what you're getting into when you get into a particular lubricant. So read through this, very important. We're going to talk a little bit about film. A film is a very thin coating of something. A film lubrication is really what you want to get in many, many cases of lubrication. You want to have that thin film across your surface or between the surfaces that are moving across each other. If you can create that film, then those two surfaces kind of often float. They don't actually really contact substantially. And you want that. As soon as your metal surfaces start actually touching each other or pushing against each other with any kind of force, then you tend to have a much higher friction. You tend to add heat, and you start breaking down those metal surfaces. So lubrication is very, very important in the concept of creating that film, that layer, even if it's very, very thin, between the two pieces of steel. As soon as you've got steel on steel action going on, you've got a problem if you want it to last any length of time. Chapter 9.3 talks about methods of application, and they do a pretty good job of that. Submersion's kind of obvious. They show you the pictures of it. Splash is a common method inside some machines. Many machines now have sprays. They have little nozzles that spray up that lubricant onto a surface, including vehicles. You'll see sprays inside of many engines. A wick method just allows like a piece of some sort of cloth-like material to wick up lubricant and then spread across a moving part using capillary action. Drip method, I want to highlight that one because the drip method is often used in many older pieces of equipment. Notice the little drawing here showing you a drip device that lets you have a little knob to change the amount of drip you get down onto your bearing, in this case, that's rotating. The drip method is old school, very old school, and you'll still see it out there, but it's becoming a little less common with modern lubricants. Why is this not ideal? Because dirt can get down in there, and a lot of thing with drip is once it starts getting dirty, you got to take apart this whole assembly, clean it, and then put it back together. Just doing a quick clean out of the drip hole isn't necessarily going to solve the whole problem. You might soon have it clogged up, and then you've got a lubrication problem again. We also have more and more automatic oiler systems, and the book shows you one of the typical automatic oilers. These are devices with sort of built-in injection pumps or built-in other devices that apply just the right amount of oil at the time it's needed into the whatever it is you're greasing, a big motor or a bearing. You'll see a lot of them out there. There's no way to kind of educate you about all the ones that are available. They just showed you a couple pictures here. Each one of these, you need to review its user manual. You need to make sure you know how you're using it properly. This section here, methods of grease application, is probably the most important section to read in this book. It just touches on a bunch of them, including the use of a grease gun. And so read through that carefully. It's only half a page. There's not a whole lot to it. The last thing that's mentioned in this section is boundary lubrication. And it talks about a concept where, well, basically, let me say that, have you ever, guys, if you've ever used a black iron frying pan, you know that in a black iron frying pan, you never use oil on that. I'm sorry, you never use soap on that black iron frying pan. I can't speak this morning, because that black iron absorbs the grease in that frying pan, and that grease inside the frying pan creates a lubrication layer. So if you fry an egg on it, it won't stick. As soon as you use soap down inside that cast iron frying pan, it will start breaking down that lubrication layer. And that combination of lubrication, which is the grease, plus the iron at that layer, that very thin black layer, is a very important thing. That is a boundary layer. It is a combination of both iron and oil in that very thin layer, and it can be broken down and destroyed. So that's a very important concept. You have to follow the procedures for cleaning anything that's lubricated, because you may be creating a problem with the chem absorption of that boundary layer. So you have to follow this, have to respect that boundary layer. A lot of times a piece of older machinery will just run and run and run until someone messes with it, cleans it a little bit too thoroughly, and then you've got some problems. So you have to very much pay attention to your correct procedure for all the older equipment, because you get that natural boundary layer that's created. And the last part of this chapter is 9-4, lubrication schedules. The book emphasizes this. I think it's extremely important that if your plant follows the lubrication schedule, that you maintain it. I think it's becoming less and less important to have, as the book mentions here at the bottom, an aggressive lubrication schedule because of the quality of lubricants. In the old days, you had to replace the oil in your vehicle every 3,000 miles. But nowadays, if you spend a little bit more on a better grade of artificial, quote, artificial, unquote, lubricant, you can go 5,000 or 6,000 miles without having to worry about changing your oil. And the same is true out in the plant, if your plant is kind of keeping up to date. As well, you'll see more and more sealed bearings out there that are designed to be sealed away from dirt, and they never get lubricated. So lubrication schedules, vitally important. You must follow them, but you have to make sure you sit within the category of the equipment that you're working on. Older equipment, obviously, you must lubricate. The newer stuff, though, you have to follow the manufacturer's recommendation.